All right, so today's lesson is actually going to involve some indeterminate forms. Now, these are two forms that we specifically looked at last year, and we are going to be looking at a few of the different indeterminate forms. Specifically today, we're looking at infinity divided by infinity and infinity times 0. Which one wins? Which one is the one that, is it going to be infinity or is it 0? And so if you could picture this almost like a fight between two strong things, which one is the one that wins? And so as we're doing these questions and approaching limits, once again, let me remind you that infinity is just a very, very large number. And so as we do this question, and I put infinity into 8, infinity cubed minus 2 times infinity squared plus 1, we're talking about a very, very large number cubed. And that even though we have a very large number squared and we're subtracting from that, it's still not as big as that infinity cubed. So in essence, when we're looking at these limits, we want to think about which is the strongest part of it, which is the part that's kind of leading the way. And so when looking at this limit, the truth is we're really just looking at the strongest part or the highest power of the top and the bottom. Let me say that again. You're looking at the highest power from the top and the bottom. So really, I don't care about the other stuff. The 8x cubed is the part that's going to win or is the strongest part. It's going to rule the top there. And in the denominator, we're looking at 4x cubed as being the winner, so to speak, the part that really is going to take precedent over the others. And so once you understand that what you're looking for is the highest power of the top and the bottom, you can real easily see that what we're dealing with here is the limit as x approaches infinity. And now what we're going to do is we're going to simplify that. The x cubes divide out, and so we have 8 divided by 4, which is 2. And I'll just put it as 8 divided by 4. We can easily see that the answer to that was 2. All right, let's look at another one. Let me just take a second, actually, to look at this another way. The reason that this works the way that it does, that we can simply look at the highest power, this is probably best to illustrate it this way. Let me just take a moment to factor out an x cubed. If I factor out an x cubed of the top, do you all follow that that would just be 8? I'd have minus 2 over x. I'd have plus 1 over x cubed. All right, hopefully you're staying with me here. On the denominator, when I factor out the x cubed, okay, for the same reasoning anyway, we're going to have 4 minus 5 over x squared minus 3 over x cubed. Now, as I do the limit, as x approaches infinity, all right, I want you to think through what's going to happen here. And before I go too far, hopefully you can readily see that the x cubes divide out. They're gone. I factored them out. They're out of that whole mess there, so I can actually divide them out. So they're gone. Now, as I put infinity back into the situation here, what I have here is 8. Why did I write infinity? I don't know. I have 8 minus 2 over infinity plus 1 over infinity cubed. Now, what's 2 over infinity? 2 pizzas divided by an infinite amount of people. If everybody got the same amount, that's 0. And 1 over infinity cubed, that's 0. And so what I'd be left with on top would be 8. In the same way, I could look at the denominator here. The 4 would stay, of course, the same, but I'd have minus 5 over infinity squared. Again, that would be 0. And minus 3 over infinity cubed, again, that would be 0. So I'd be left with 8 over 4, and another way of demonstrating the fact that the limit as x approaches infinity really just requires me, when I have infinity over infinity, is to take the highest power of the top and the highest power of the bottom, simplify, and look at it again. And of course, this simplified to be 2. I hope that makes sense to you. Let's try another thing here. Let's do another example. Limit as x is approaching infinity. So I have e to the infinity over infinity cubed. Well, which one wins? The bottom line is you want to look at the stronger function. Which one is increasing at a faster rate? Although they look quite similar, x cubed is, of course, that cubic function that, and then you have e to the x which starts woo, and then it jumps right up. An exponential happens faster by far. E to the infinity is the one that takes precedence. So when I'm looking at, oh, e to the infinity, that equals equals infinity, I can easily see that even though this was infinity over infinity, the stronger function wins. All right, let's try another one. Infinity squared over e to the infinity. E to the x, if you haven't gotten this from last year, e to the x always wins. And so in essence, this is just like having a number over infinity. This amounts to less, it's lesser of a function than e to the x. And so this one would actually be 0, technically 0 plus, but it would in fact be 0. Remember, the CLEP exam, they don't distinguish between 0 plus and 0 minus. The answer to that would simply be 0. All right, let's try another one. Limit as natural log of x over x. So again, I'd have the natural log of infinity over infinity. And as we just mentioned, that the stronger one wins. When we're talking about natural log, the weakest of functions, it moves incredibly slow. It really climbs at a very, very low rate. Even x trumps that. This is really just like having a number divided by infinity, and so this would be 0 plus as well. Okay, let's try another one. Now we've got negative infinity, and we're going to cube that, e to the negative infinity. Before I go too far in evaluating this, once again, you want to look at which one is the stronger function. And since e to the x is the stronger function, really this is a moot point. It doesn't really matter at all. And so we have, in essence, negative infinity times 0, though. And so if it makes you feel better, you have that 0 there, and technically it'd be 0 on the minus side because that negative does play a role. Okay, so we have 0 plus, and then I have the natural log of 0 plus. Now I told you that natural log is the weakest of functions, but when you look at this particular equation, you have x, he's moving, and you have the natural log function. Natural log is your weakest function, okay? And so in evaluating this, the tricky part about it is understanding that this is moving very fast in the negative direction because 0 plus at that spot, that slope there is incredibly fast. Normally, natural log, of course, is weak, but that's really as we're talking about moving towards the positive infinity. But 0 plus, as we're getting very close to 0, that is happening incredibly fast. And so we have 0 and we have negative infinity. And of course, the negative infinity would trump this one because it is hitting negative infinity faster than x is getting to 0.